So for this section, it's a quick section on momentum and impulse. So when you think of momentum, momentum is basically the laziness of an object, the difficulty it is to stop that object based on its mass and its velocity. So momentum is resistance to change in motion of a moving object. So if you thought of like a train or maybe a school bus, a really big bus, a big bus wouldn't really matter how fast it's going because it's got lots of mass. So even if it had a really small velocity, it would be really hard to stop. Momentum and inertia, momentum is dependent on velocity and mass. Inertia is dependent on mass only. So mass dependent. And mass and velocity dependent. So if you look at these objects, here, these four objects, ping pong ball has virtually no mass, so it has a low inertia. It has a very low momentum, even though it's going 20 meters per second. It's really not, it really doesn't have much momentum at all. Train moving at 20 meters per second, it's got a very high inertia. It doesn't want to move, and when it does move, it doesn't want to stop, so it's got a high momentum. A train at rest, it would have a very high inertia because it doesn't want to move, but it's at rest, but it still has inertia because it has mass. But if it's got a velocity of 0, then it would have 0 momentum. A bullet traveling at 500 meters per second, we'd say it has a low inertia, but it has a fairly high momentum. Not as high as the train, obviously, but it still is enough to push through something. So the equation for this is P equals mv, and P is equal to momentum. And m is mass, and v is velocity. And it is a vector, so you got to think about this. Velocity is positive or negative, so this is definitely positive or negative. In some textbooks, you actually see a line over the top that indicates it's a vector. It might be an arrow or just a straight line. So the first example here is you've got what is the momentum of a bullet that's got a mass of 0.01 kilograms traveling at 500 meters per second. So for my mass, I've got 0.01 kg. I've got a velocity of 500 meters per second, and that's positive, so it's to the right. And I'm looking for a momentum here, so it would be P equals mv. And that would give us 0.01 multiplied by 500 meters per second. And actually, I left out my units, so let me go back and put that in. 0.01 kilograms multiplied by 500 meters per second. And that would give us 500 kilogram meters per second. And the unit doesn't cancel out. There's nothing common here at all, so you end up with the same, the units just not canceling out. Conservation of momentum. In a collision, you've got what's called elastic collisions and inelastic collisions. So when you have an object, let's say, that's traveling at a velocity, at some velocity, and it's got some momentum, so let's just give it, we'll say it's got P. We'll say that's P initial. If it crashes into another object, all right, and this object has a momentum of 0, so this object 1 and 2, if all of the momentum is in this guy here and he crashes into this guy and then they stick together, we call that inelastic. And what would happen is we'd measure the momentum, and I'll put a shorter line to indicate that the momentum final is actually a little bit less. But if we add up the momenta of this guy and this guy, they have to come out to whatever the after situation is. So the definition for this is that momentum initial, and I'm just going to write an equation, P initial is equal to P final. And that just means the momentum of all of the objects, not just one. So if you think of like a stick of dynamite, and a stick of dynamite blows up, the initial momentum of that dynamite is 0. So what would happen is when it explodes, it breaks into, and I'll do the best I can to draw this, but it breaks into maybe 3 pieces, and I don't know, another chunk over here. These all have momenta, and so if you added them up, they would actually come out to be whatever the initial momentum was, which in this case is actually 0, and it would be it would come out to 0 because these guys are all moving on vectors which have positive and negative components. So think of if I took a cart with a spring and I crushed it together, and they would push out in this direction here. This one would have some velocity, and this would have velocity, which would mean that they'd have momentum, and that they would be it would have to add to 0 because they were initially at rest. When we're doing problem solving here, you want to always start with this equation here, which is P initial is equal to P final. So on the AP exam, if you indicate that you understand the concept, or you can indicate that by showing this equation here. Now I know that really if I'm talking about two objects, this is the momenta of two objects. So it would be something like this, M1v1 plus M2v2, if I was talking about a scenario like this here. So I've got mass 1 and mass 2, and they're both at, one's moving, one's at rest, so that would have to equal what they are when they're stuck together. So we would say M1 V1 plus M2 V2. And this would be their final, so we sometimes put a prime symbol there, which just means the final. So anytime you're doing problem solving here, you're under the assumption that all momentum is conserved, and it is conserved. You know, I shouldn't say assumption. It is conserved if you're talking about not applying any sort of force of friction at all. So this example here says you've got a stationary car that's struck by a 200 kilogram car traveling at 30 meters per second. The 30 kilogram car moves off at 25 meters per second. What is the velocity of the 200 kilogram car? So this is, I'm approaching this from the idea of P initial has to equal P final, and that's total initial and total final. Well, what do I know about the initial? I know it's actually two objects. I know it's M1 V1 plus M2 V2. It's got to be equal to the final, which is M1 V1 plus M2 V2. And if you're asking, well, where'd you get these M's from? Well, P is equal to MV, and that's just for one particular object. So if I've got one car crashing into another over here, that's my initial scenario. So let me substitute my masses. I'll make this guy over here M1 and this guy over here M2. So I end up with 200. All right, I'm going to leave my units out because I'm kind of moving fast here. Velocity of that guy, of this guy here, is 30 meters per second plus, and then this guy's stationary, so it's 300 multiplied by 0, and that's got to equal. And it says here they're not stuck together because one moves off at 25 meters per second. So the 300 kilogram guy, we know his velocity. The 200 we don't. So it's 200, right, times V1 plus 300 times 25 meters per second. And if I simplify this out, I get 6,000 here plus this equals 0 equals 200 V final, actually V final of the first object, and then plus, and then this ends up being 7,500. So just be careful algebraically here. These are vectors, so it doesn't say you know, any sort of direction of the problem. It just, you know, implies stationary, and one object is moving to the right, we assume. So just be careful with your signs here. So we end up with 6,000 equals 200. I'm just going to put X there plus 7,500. So now I subtract from both sides 7,500. And I'm going to move this over here. I get negative 1,500 equals 200x, and then divide both sides by 200. And I get negative 7.5 meters per second, which makes sense here because in real life what's happening is you've got a car here which has a mass, and you've got a larger car which is struck by that mass, and it bounces off of that guy and it actually ends up going in the opposite direction. And it's not necessarily because he's got a low velocity or a high mass. It's a combination of those two, but we know that this car absolutely has to be going that way. So this comes out to a positive number, this one's a negative, and sometimes that, if this was a larger mass, it would actually continue in that direction. But the negative just tells me that he bounces off and moves in the opposite direction. In this case, it says a 400 kilogram car traveling east collides with collides completely inelastically. Inelastically means it sticks together. So in the last problem it was elastic. This one is inelastic. They stick together with a 600 kilogram car moving at 8 meters per second. What is the velocity, west by the way, what is the velocity of the cars after the collision? So again, if I sketch a diagram here, this guy is traveling in this direction, and then the larger of the two is traveling in this direction here, and they're going to collide with each other. And we want to figure out, once they stick together, what that velocity will be. So again, the same scenario here, we're going to take this equation, start off with this idea that P initial total is equal to P final, and then we're going to take this and say M1V1 plus M2V2 is equal to M1V1 plus M2V2. And so if I fill in my variables, I'll pause for a sec. I just need to be sure that I include this as a negative number because it's west. So if I simplify this, I can really just add these two masses together because they both have the same velocity when they're stuck together. And they'll maybe be going that way, maybe going this way. We won't know until we're done. So if I simplify this, I get 6,000 plus negative 4,800 equals 1,000x. So for this part here, I just add these two together. And I get 1,200 equals 1,000x, so I divide by 1,000, I end up with 12 meters per second. Now, that's my final velocity for both, so I just put VF. And that's the velocity towards the right because this it's a positive number. Now, if this were a much smaller object, maybe you're going slower, then you could end up in a situation where it was going in the opposite direction. In the next problem, you've got a 2 kilogram rifle that fires a 0.05 kilogram bullet at a velocity of 500 meters per second. What is the recoil speed of the rifle? And again, it's the same concept here. P initial is equal to P final. And in this case, the initial velocities of both objects is actually 0. So it's M1V1 plus M2V2 is equal to M1V1 plus M2V2. And so this entire side of the equation is 0. It's 0 because when you multiply the mass times the resting velocity, you get 0. So for this here, we know that the bullet travels at 0.05 multiplied by 500 meters per second. I'm going to make that to the right, and then that's going to be plus 2 kilograms multiplied by some unknown velocity. So we don't know the final velocity of that guy. So if I carry this out, I end up with 0 equals 25 plus 2 times VF. I subtract 25 from both sides, so I get negative 25 equals 2 final velocity, and then divide by 2, and I get negative 12. Now, it makes sense that that's a pretty low number because it's the recoil of the rifle. That's still pretty fast, but you understand that it happens over a split second, so it recoils into the guy's shoulder until his shoulder stops it, over a fraction of a second. Just a couple quick things here. It's a vector. Momentum is definitely a vector, so when you're talking about some kind of force, let's just say a ball bounces off of the wall, there's a force that's going to make that happen. So if it has some momentum, P initial, then that P final should be the same value, but just it means that there's some sort of change in momentum caused by a force that makes that happen, which brings us to the next section with impulse. And impulse is defined by any change in momentum. And so it's this idea that if you've got an object like this cart and it's traveling with some initial momentum in this direction here, if I want to stop it, speed it up, slow it down, whatever I want to do, I've got to apply a force to make that happen. So maybe I apply a force this way or I apply a force this way. And I've got to do that over a set period of time. And depending on how long I apply that force, it will dictate how much momentum it gains or loses. So impulse and force gives us this equation here, F times T is equal to delta P. And then I also know that change in P is equal to mVF minus VI. And that just means here that if I'm applying a force over a certain period of time, then I'm going to experience a change in momentum here. So I can combine these two equations to give me mVF minus VI equals F times T. And so this describes what's happening when I apply a force. Think of like a rocket. A rocket basically applies a force over some time, and it causes the velocity of the rocket to change. So what is the impulse force necessary to speed up a 20 kilogram car from rest to a speed of 4 meters per second in 0.5 seconds? My mass here is 20. My initial velocity is 0. My final velocity is 4 meters per second, and t is 0.5 seconds. So now they're asking you for what impulse and what force. So impulse is just change in p. All right, this is impulse. And we also know that change in p is equal to F times t, but I don't have this, I don't have force. So I'm looking for that force. So